Good morning and welcome to today's lesson. Our lesson today is on the topic sequence and series. In this topic, we are going to look at two subtopics. One is known as sequences, and then the other one is series. A sequence, as you know from the general knowledge, is an arrangement of items in a certain way, in a certain order. So mathematically, when we are talking about sequences, we are going to be looking at a list of numbers which are arranged in order. So for you to get that list, you have to follow a certain rule, a general rule, such that if from the list you want to get item number 10, there is a rule of getting that item. I'll give you two examples of lists of numbers here. Then you tell me whether they qualify to be sequences or not. So we have 0, 3, 6, 9, 12. It's a list. And we have 0, 5, -1, 10, -14. Another list. So if you look at these two sets, you will find that in the first example, you move from 0 to 3, 3 to 6. There seems to be something that is happening. For you to get 3 from 0, it's like you are adding 3. Then you continue adding 3. To go to the next one, you add 3. To go to the next one, you add 3. So you know even to go to the next, you add 3. And the next, you add 3. There's a pattern that is being followed. And there's a rule that's being followed. You are adding 3 as you move to the next. So this first one is a sequence. So is a sequence. What about the second one? 0, 5, -1, 10, -14. Look at it. Is there any rule that is being followed here? Is there any pattern that is being followed? Can you be able to know the next number? I think if you apply all the reasoning and all the rules, you will not get any rule that is being followed here. There is no pattern. They're just numbers which have been written without following any pattern. So the second set here is not a sequence. So not all lists of numbers qualify to be sequences. A sequence must follow some rules. It's a pattern. There's a pattern which is coming out, and you can be able to tell the next rule. Under this topic, we will look at 3 types of sequences. 2 of them are going to be key. One will just to introduce ourselves to the topic. So we are going to look at general sequences for now. The aim of looking at general sequences is to see whether we can be able to come up with a rule. If you're given numbers like you're given these numbers, 0, 3, 6, 9, like that. Now, you know the next one will be 12 because you're going to add 3. And the next one will be 15 because you're going to add 3. For now, we can call this one a general sequence. I have said for now because as we move on, we will be changing its name to another type of a sequence. So when you are given this and you are asked to find the general rule or the rule that can give you the general term. In this topic, the general term is normally given the letter N. So we will be getting the end term. How do you get the end term? If I want to go all the way to an end here, where n is not specified in this case, how do I do that? You're going to look at this, and there is no specific formula for that one. For general sequences, there are no specific formula of getting the rule. So it is a trial and error. For example, here, when we have 0, 3, 6, this is the term. So we call this term, it's first term, second term, third term, like that. So n is the number of terms. So if 0 is the first term, then it means here n is 1. And here n is 2. And here n is 3. So n here is referring to the number of term, the nth term. 0 is the first term, so n is 1. 3 is the second term. 6 is the third term. 9 will be the fourth term. Because for the number of terms, you don't skip. It's 1, 2, 3, 4 like that. So you can go up to the 10th term. So if you look at the first term here, it is 0. The second one is 3. So you can do trial and error. So if when n is 1, the answer is 0 here. And when n is 2, the term itself is 3. You can try and look at the rules. If you multiply 3 with the n, and then you subtract 3, let's try that for the first term. So it means for the first term, n is 1. So if you substitute 1 here, you get 3 minus 3, 0. Seems to be working. Try and error. For the second term, n is 2. Put 2 here. 2 times 3, you get 6. 6 minus 3, you get 3. Seems to be working. So for general sequences, you use trial and error to get the nth term. That should not worry you, because in most cases, nobody would ask you to do that. It is mainly a question that does not have a certain way of doing. Sometimes you can be given a general rule and you come up with a sequence. That one is a common one. For example, you can be given a general rule of 2n minus 3. And then you are asked to write the first 5 to 2. 2 times 2, you get 4. 4 minus 3, you get 1. So that will be the second term. The third term, substitute here, n is equals to 3. So 3 times 2, you get 6. 6 minus 3, you get 3. That is the third term. Substitute now n is equals to 4 for the fourth term. You get 8 minus 3, which is 5. Then substitute n is equals to 5 for the fifth term. You get 10 minus 3, which is 7. That is the sequence we are looking for. So it's easier when you are given the general term or the general rule to come up with the terms. But it is also possible for you to be given a sequence and then you come up with the general rule or the general term that is being followed. So we are going to get there for now for this lesson. For general sequences, they don't have a particular way of knowing the general rule. You have to use try and error. So you will do an exercise on that. Try and exercise your skills and see how well you can be able to get the general rule. And also, given the general rule, see how you can be able to come up with the sequence that is being given. So in our next topic, we are going to look at another type of sequence, which is known as arithmetic sequence. So thank you for now and have a nice day.